Well, I think this topic on microfabrication is helpful, especially for researchers or students who want to start the fabrication of microfluidic chip or digital microfluidics. Before you start microfabrication, you need to design the type of device you want to fabricate. You can use a computer-aided design software or known as CAD software. After design, we specify the type of photomask you need, either positive or negative. The photomask will have two parts. The part that will enable the removal of metallic film on the area of substrate, and the part of the mask that will enable to keep another area of metallic film. This is the drawing. And we have those two parts. The first part is the black part, The part that, this is the part that will enable the removal of the film on the substrate. Here, when exposed to UV illumination will not create an effect to the substrate. And during the development followed by etching, this part will be affected, or the film on the substrate is removed. The second part is the white part. The white part is the part that will be exposed to UV illumination and will remain after etching of the metallic film on the substrate. Here are examples of mask, photomask, and the chromium electrode on a glass substrate. After getting your photomask, you need to coat a metallic film on the substrate. With this instrument, you can coat a metallic film on a glass substrate. The system is fully automatic and easy to use. You just turn on the instrument, and sometimes you need to check if its pumps are open. And if not, you need to open. You go to the screen and select the type of metallic film you want to coat. This instrument is sometimes set to coat chromium, platinum, and gold. For chromium-based device, you can select chromium, and then select the thickness, usually 300 nanometer, and select minute, and run the instrument. It will run itself and open when the task is finished. Before coating photoresist, such as AZ photoresist, the sample is first cleaned using a plasma cleaner. You need to set the pressure and the time. For example, 600 bar for 30 seconds. Then you proceed to photoresist coating. You set parameters depending on the thickness. After coating photoresist, you put on a hot plate at 100 degrees C for between 1-2 minutes. Then you expose your sample through mask with mask aligner. After you put the sample into development solution, which removes the photoresist from the area not exposed to UV illumination. After development, a dielectric thin film is coated, such as SU8, and then after hydrophobic layer, such as Teflon. There are other types of hydrophobic layer that can be coated to make the surface hydrophobic. Thank you, and see you in the next videos.